Imagine this. It's been a long day, and you finally have some downtime to unwind and play your favorite online racing game. You launch the game, queue up, and enter a match, but soon you realize that something is wrong. One player in particular seems to be crushing the competition, and when they lap you, you realize that their car is moving twice as fast as yours, far beyond the max speed in the game. How is this possible? Well, this person happens to be cheating using a hacked game client. The match is ruined. We've all been there, and it is not fun. Not only is the match ruined, but maybe your whole night is ruined when it keeps on happening. Eventually, you stop playing the game altogether and you move on to something else. The situation that I just described is a nightmare for game developers. Their player base can't trust the game to be played fairly, the game loses monthly active users, and the game's revenue subsequently dries up. A global gaming survey conducted by Erode found that 60% of online gamers have felt negatively impacted by other players cheating on multiple occasions. Furthermore, 77% of online gamers would likely stop playing a multiplayer game online if they thought others were cheating to gain an unfair advantage. It's clear that cheating is a big problem for gamers and game developers alike. Hey everyone, I'm Nathan Yim, a product manager on the Firebase team, and I'm here to share how you, as a game developer, can combat various forms of cheating in your game with Firebase App Check, an exciting new feature coming soon to the Firebase SDKs for C++ and Unity. But first, a quick refresher. What is Firebase? Firebase is Google's app development platform that helps developers build and grow apps and games that users love. Each phase of the game development process requires different tools. From building your game, to releasing it, to operating it, Firebase provides the tools you need to be successful. As a comprehensive, well-integrated development platform, Firebase offers a variety of products from fully managed infrastructure so you can get your game to market faster, to crash reporting so you can ensure your game is bug-free, to machine learning-powered personalization capabilities so you can deliver the best optimized experience for your players, just to name a few. Millions of apps and games trust Firebase today to help them reach and engage billions of people across the globe, and we're constantly working to serve the evolving needs of developers everywhere. Today, we're going to tell you about App Check, one of our newest products focused on strengthening app security. We'll cover what App Check is, some common forms of cheating in games and how App Check works to combat them, and then we'll show a quick demo of how to easily add App Check to your project. So let's jump in. So what exactly is App Check? Well, when you're building a multiplayer game, you'll typically need to make decisions that can come with some risk. Things like placing some level of trust in your game client to behave properly or send accurate data to the server, or connecting to a database to exchange information, say post-game stats or a player's character level, or calling various other APIs to get any other services you need. Game client impersonation, billing fraud, phishing, and data theft are all risks that, frankly, you shouldn't have to worry about. And that's where App Check comes in. App Check protects your APIs by attesting that incoming traffic is coming from an authentic version of your game on a legitimate device and blocking malicious traffic that's not. Using the combination of app identity and device integrity, you can rest easy knowing your game is the only one talking to your APIs. Whether you're building the next hit indie game in your garage or managing a multiplayer game at AAA scale, App Check helps protect your backend resources from abuse and unauthorized access, which could otherwise ruin your game, or in some cases cause your infrastructure bill to skyrocket. Even better, you can use these App Check protections with Firebase, Cloud, and even API endpoints on your own custom servers. App Check is integrated with a number of attestation providers, including Play Integrity for Android and Device Check and App Attest for Apple platforms. Custom attestation is also supported for all platforms. Next up, you'll be hearing from Joe, who will be diving a little deeper into how cheats make their way into games and how App Check works to protect against them. Take it away, Joe.
Hey all, I'm Joe Spiro, and I work in developer relations on Firebase. In addition to real-time multiplayer, such as the example Nathan brought up earlier, asynchronous interactions like competing in leaderboards are also often the target of cheating. Imagine for a moment you just completed the most recent solo challenge in a hot new puzzle game. You did amazing, but find yourself a little disappointed and a good deal awed to see that the only person who beat your score did so by tripling it? Humbled, you're just happy to be on the leaderboard, but out of curiosity, you decide to watch their replay footage. What happens in the replay shocks you, as their pieces do nothing, and all the other pieces jump around in a whirlwind of motion, totally disregarding the rules of the game. All the while, every sound effect in the game plays at once, causing a cacophony of noise necessitating the removal of your earphones. Speechless, you wonder to yourself, what just happened? You guessed it, the answer is cheating. In a normal asynchronous game, players proceed through their round on their client, eventually getting to some sort of results screen. When this happens, the game sends a message to the backend with the result: win, lose, score, placements, etc., and possibly some metadata, including things like replay information in this case. Assuming you've set up your security rules in the Firebase console, your game's API endpoints and the database will filter out submissions from accounts and clients that aren't signed in or lack the appropriate permissions. If the submissions pass these criteria, the server will write them to the database, in this case representing the leaderboard. Unfortunately, even unauthorized requests that fail to pass your security rules and therefore don't reach your records or game logic can cause a traffic jam, costing both time and reliability. So where did this fraudulent submission come from, and how can you prevent them from wasting your time and resources? Well, to understand this, let's talk about two of the more common categories of cheating in online games: client modification and unauthorized API traffic. Client modification is, exactly as it sounds, the altering of a game client, either through modifying a legitimate install or making a totally new client that mimics the behaviors of the official one. They can be made to give players unfair assists, like cheats, including aimbots, wall hacks, unlimited health, etc., or even to fully spoof communications with other players in the backend in order to gain an advantage. This frustrates players, drives them away, and ultimately diminishes the game's revenue. Spoofed API traffic can also originate from an altered client, but can instead be generated entirely artificially by reverse engineering and constructing the API call directly on a network-connected device and sending it to your services. If a cheater uses either of these methods with a valid authenticated account, your security rules won't filter them out, and voila, they can submit illegitimate data and start undermining your game and eventually your bottom line. Historically, devs have played the cat and mouse game of trying to solve these issues with band-aid solutions. A common treatment is to submit replay data along with high-score submissions and then re-simulate it in-game to determine its validity. However, there are a couple of issues with this approach. For one, cheaters can still submit faked, perfectly precise play that falls within the bounds of the in-game rules. These submissions are even harder to differentiate from authentic ones submitted by your most skilled players. Erring on the side of over-enforcement, and therefore some false positives and bans, can cost you some of your most devoted players. Secondly, it can get computationally costly to re-simulate every single submission received. There's got to be a better way, right? This is where App Check comes in. App Check requires all traffic to your endpoints to come with a proof of authenticity, an attestation. At a high level, valid clients will first contact an attestation service which can validate that the client is not altered and will provide a token the client will cache and use in its subsequent request. Once App Check enforcement is enabled on your APIs, incoming requests sent without attestation, or with falsified attestation, are rejected with a 401 response before ever hitting your security rules, let alone any additional checks you may have added, such as validation via simulation. This prevents unauthorized requests from hitting, loading, and abusing your backend resources altogether. Let's consider one last scenario. What if, instead of a modified client or spoofed requests, a cheater uses a valid install of an unmodified game on a modified device that, let's say, has a program that dynamically attaches new code to your running game in a process called hooking to replay recorded inputs? Inspecting the game client on disk and how it's installed would have no hope of catching onto this sort of scheme, as the install remains unaltered but its running image and memory is modified from outside. You're in luck. App Check and the attestation providers it has offer built-in support for not only verifying the game is unmodified and that its installation was valid, but whether the way it is being used shows signs of compromise. Looking back on the network map, valid installs of unmodified apps running with injected code can be set to be rejected by the attestation service directly or generate a less trusted attestation your server can be told what to do with. For a little demonstration, let's talk about the case where your game is communicating directly with Firebase backend resources. How do you go about adding and activating App Check? It's simple. In the Firebase console, go to the Build section and click App Check. Add the desired app and select an attestation provider. In your C++ or Unity project, you need to add the App Check library and then specify in code which attestation provider to use before you initialize your Firebase app. Finally, all that is left to do is tell Firebase to enforce App Check. It's really that easy. Now I can spend more time on player enjoyment and less on worrying about cheaters using hacked game clients that will drive the player base away, or about illegitimate API calls to my backend, which could drive up my operational costs. Just know that you need to make sure older clients that cannot use App Check are an acceptably small fraction of your users before doing so. In the meantime, you can incentivize users to upgrade to the newest version. If messaging Firebase backend resources, that's all you need to do. Firebase resources will now automatically receive and inspect attestations on incoming traffic. If, on the other hand, you're securing your own backend, AppCheck provides customizable ways to use different attestation providers and send their results along with your message to be validated by your own server logic. Detailed instructions on how to do so are available on the Firebase website if you are interested. We hope this demo gives you an idea of how straightforward it is to add AppCheck to your game, and we can't wait for you to give it a try.
We are so excited for game developers to try out AppCheck in their mobile games with the Firebase SDKs for C++ and Unity. While you can never catch all cheaters, using Firebase AppCheck is a great way to combat the most common forms of cheating in your game. Now you can rest easy, knowing that your backend resources are safer, which will keep your players happy and ultimately your revenue protected. Keep an eye out for Firebase App Check, coming soon to the Firebase SDKs for C++ and Unity. Thanks for watching, and see you next time.